We're just going to do something that is a slight variation on what we've been doing, which is to find the critical regions. I think you're going to find this pretty straightforward as well, okay? It says that, again, we've got a random sample of size n taken from a population having a normal distribution with mean mu and variance sigma squared. Find the critical regions for the test statistic x bar for the following levels of significance. So you'll notice the information that I haven't given you here is actually what happened when I took a sample, okay? This time, I'm just telling you that the average is 45, or we think the average is 45, the null hypothesis is that the average is 45. We have a suspicion that the average might be bigger than 45, and we're going to take a sample of 10 things. The standard deviation of the population is 3, and we want to find out to a 10% significance level. We want to say, if I took this sample of 10 things, what would be the value of that average, that sample mean? What would the value be to make me say, actually, the average is bigger than 45? So first of all, what kind of number would you expect the critical region to be for this kind of scenario that we have here? Just roughly, what number might it be? Is it going to be bigger than 45? Is it going to be smaller than 45? Pardon? Bigger, why? Good, because we're interested in the idea of it being bigger than 45, so it makes sense that the statistic of taking a sample and finding its mean, we'd expect it to be bigger than 45. So we'll start off and say, again, I'm just going to write these things out. The null hypothesis is that mu is 45, and the alternative hypothesis is that mu is greater than 45. What we're going to do here is we're going to assume that H0 is true, just like we did previously. So that means, seeing as we're talking about this x here, that x bar will be normally distributed with a mean of 45 and a standard deviation of, a variance of 3 squared over the number of things, which is 10. So you might like to, somewhere on your page, say, okay, well, that means that the standard deviation is what? 3 over root 10. Now, what I want to do is I want to find what is the probability that x bar is less than or greater than a particular value. I want to say, what's the probability that x bar is greater than a particular value, and I want it to be less than 0.1. Let's just break down what this is saying here, okay? I'm trying to say, what value of A would be the start of the critical region, that the probability of something being bigger than that value is significant, is less than 10% for this particular case that's a 10% level. So thinking about what that might look like on a diagram, if the mean in the middle is 45, and I want to know what is the value of us thinking that it is bigger than 45, I'm saying what value is it over here where this probability is going to be 0.1. I'm trying to say, what is this value A?
46.
So I'm going to use my calculator to come up with this particular one that I've got here. Now, the graphics calculators, you can do it as the right tail and say that it's 0.1. But non-graphics calculators, you can say that this area over here is 0.9. So we're actually working out the probability that x bar is less than a particular value has got to be less than 0.9, greater than 0.9. It doesn't really matter because it's just going to end up as that. So we'll go to the calculator and we'll fill this in. Okay, so this time we have to use, what do we have to use on the calculator this time?
Inverse.
The inverse, good. So we'll go normal, inverse. We're going to do the left tail of 0.9 because that's what the calculators everyone has. The standard deviation, was it 3 over root 10?
Yeah.
3 over root 10, and the mean was 45?
Yeah.
And so we get 46.2. So we get that A is equal to 46.2. So the critical region is if x bar is greater than 46.2. Because if this value became 46.2, then, or bigger, you would have that it is less than 0.1 and it would become significant. So there's this extra step of just doing the inverse probabilities. So this one I don't have to accept or reject, okay? But what would happen here is now I'm going to tell you, I did an experiment, I took a sample of 10 of them, and I measured the sample mean, and the sample mean was 46.15. What should I do if the sample mean was 46.15? Good. There is not enough evidence to reject H0 because 46.15 is not in the critical region. Now, it makes sense that it has to be bigger than 46.2 because if you measured 10 things and you got an average of 48, you would be like, wow, that's really, really far above the standard, really far above the population mean. That makes me think that I should reject that and say that the mean is greater than 45. So let's try this next one that we've got here. Null hypothesis is that the mean is 100. Alternative hypothesis is that the mean is not 100. So as soon as you see not 100, we're like two-tailed. If it's two-tailed and we're doing critical regions, we need two critical regions, okay? And it's also going to be a 2.5% level because it's two-tailed. So I'm going to assume that H0 is true. So X bar is going to be normally distributed with a mean of 100 and a standard deviation of, a variance of 15 squared over 40. In other words, sigma is 15 over root 40. And we're interested in the critical regions. And the critical regions are these ones, where we have a value here, and I want this probability to be 2.5%, 0.025. And I'm also interested in this other value down at this other end, where this value is going to be 0.025. Now, if you find these symbols a bit confusing, just find the value that gives you the probability of 0.1 and then set it afterwards. So if we're going to do that in that kind of way, if I'm saying, okay, I want to find out the probability that x is less than a is equal to 0.025, I'm going to now put that on my calculator to find out what that value is. So I'm talking about the one that's on the left-hand side, and I want the area to be 0.025. So 0.025, sigma was, I can't even remember from the previous page, what was it? 15 over root 40, and the average was 100. So we get 95.35. So here, A is 95.35. And you should tell yourself, does this make sense? Well, it does, because the average is 100, and we've said it's 95.35. So this critical region is what? That x bar is greater than or less than 95? No. This is the critical region down here.
Oh, it's less than.
So it's got to be less than 95.35. We then do the same for the other end. This time it's the probability that x bar, or we could either do it for the other end or we could say that it's less than b. What would be the probability it's less than b? 0.975. Good, 0.975. So we can just go straight back to the calculator. If you've got the graphics one like me, you could just switch it to the right tail, but we can do 0.975 and you get 104.65. So B is 104.65. So 1 second, the critical region is that x bar is greater than 104.65.
So why were you finding that all of that on the left?
So the reason was just because on your calculators, you want this region on the right to be 0.025, but instead of trying to do that on my calculator, I can just do the same thing and say that the region on the left is 0.975 because they add up to 1. Okay, it's just so I can save a bit of time. Like here, I went from 0.1 to 0.9. It was going from 0.025 to 0.975. So I've measured 40 things, and I got that the average was 102. What should I do?
Write it together.
No, I don't have to write it together. I've got my two critical regions.
102 is bigger, so
Is it? Where does 102 live?
In between the two.
It lives in between them, so that's not significant. So that was my top one, 104.65. If I had 102, it's in this middle region, so it's not enough evidence to reject H0. If you measured something and it was 94, you would say, okay, well, it's in this critical region down here, so I can reject it. I can reject H0 and I can accept the alternative hypothesis. So these ones, I think, are a bit easier than doing the critical regions for binomial. This one is just, can you use the inverse thing on your calculator? So let's have a look at the worded question that I've got. I'm just going to get rid of that. That annoys me. Can I go to the next page?
Yeah.
So a machine produces bolts of diameter D where D has a normal distribution with a mean of 0.580 centimetres and a standard deviation of 0.015 centimetres. So I'm just going to write that down. I'm just going to grab the information that I need. 0.58 or 0.580. The standard deviation is 0.015. The machine is serviced, and after the service, a random sample of 50 bolts from the next production run is taken to see if the mean diameter of the bolts has changed from 0.580 centimetres. The distribution of the diameters of bolts after the service is still normal with a standard deviation of 0.015. That's just telling us that everything we already know, to be honest. Find, at the 1% level, the critical region for this test, stating your hypotheses clearly, and then we're going to actually go in to see if something is going to be significant or not. So what do we think that the null hypothesis is easy, so I'm going to say that one. The null hypothesis is that the mean is 0.58. What's the alternative hypothesis? Good, that the mean is not equal to 0.58, because it says here to see if the mean diameter of the bolts has changed. It doesn't say bigger or smaller, it just says has changed. So we know that the significance level was 1%, so we're going to be doing 0.5%, and I always do this wrong on my calculator. 0.5% is 0.005, okay? I always do that wrong and put in 5% instead, because it just looks too small. So that's what I'm going to be using. I am going to assume that H0 is true. And so now I know that the diameters, the sample mean of the diameters, I'm going to use the letter D because they've used the letter D at the beginning of the question. The sample diameter means are going to be normally distributed with a mean of 0.58 and a standard deviation of, sorry, I always say standard deviation, a variance of 0.015 squared over 50. So that means the standard deviation that we're going to use is 0.015 over root 50. And bless you, I want to find out for my two-tailed test here, I want either end of the test to be 0.005. I'm going to call that one A, that one B, and I know the middle is 0.58. So I want to say, what's the probability that D bar is less than A if it's equal to 0.005? And that's where I go to the calculator to use the inverse bit. So it is 0.005. The standard deviation is 0.015 divided by root 50. 0.015, is it?
Yeah.
And the average was 0.58.
where's the area?
5e to the e minus 3 is just 0.005. Because if you look here,
Oh, it's E times 10.
the area of this section is 0.005. So I'll just show you that I typed that in and it just changes it on the calculator.
Oh, really good.
0.005 is just 5 times 10 to the minus 3. That's what it's coming up with. Okay, so when I hit execute, you get 0.5745. That's 0.5745. So we get A is 0.5745. So the critical region is that D bar is less than or greater than that?
Less than.
Yeah, because we're talking about this region all the way down here. Less than 0.5745. My other end of the tail is going to be this bit.
D is greater than B.
So I'm going to say the probability that D is either greater than B, but I'm actually going to say it's less than B, and I'm going to say that the area is, what would this area be? 0.995, yeah, 0.995. That was coming from doing 1 minus 0.005. So I can then go straight to my calculator, and I can switch that up as 0.995. Same sigma, same mu, and you get 0.5855. 0.5855. Did I say 55? I can't even remember.
Yeah, 5, 5.
0.5855. Now, you should notice something here. This one has increased by 0.0055, and this one has decreased by 0.0055 because it's a two-tailed test, so it is going to be symmetrical. And it's also been symmetrical if you think about it. On the previous page that we had here, it was 95.35 and 104.65. It went up 4.65 and down 4.65 because it is symmetrical, okay? Now we've got the critical region for this. Is that D bar is greater than 0.5855. That was part A of the question. That's probably a 5-mark question. Part B of the question. The mean diameter of the sample of 50 bolts is calculated to be 0.587. Comment on this observation in light of the critical region. Now, is 0.587, is it in the critical region? Yes. So we would say 0.587 is greater than 0.5855, and so is in the critical region. So we now say there is evidence to reject H0, and we then want to put it back in the context and say this supports that the mean diameter has changed. This supports or suggests that the mean diameter has changed. 1 mark for this, 1 mark for this. Make it crystal clear that you put a mark in context for it, okay? So it's the same thing, but just using the inverse part on your calculator. And what you're going to do for me is there's only one question in the exercise about critical regions. Now, before we just wrap this bit up here, you can do any of the questions using critical regions or using the calculator. I think the calculator is probably quicker to just decide if the probability is different or not. There is, though, something I wanted to mention. When you look on Solution Bank or when you look on some mark schemes, there is a different method that some people will have done to do these questions. I'm very briefly going to tell you what it is, but I don't like it and I don't want you to use it. Okay, you can use it if you wanted it to. I'm just going to go back to some of these questions here very, very briefly. You may see a different version of this where instead of comparing probabilities, what they do is they convert this value into its z value. Do you remember what I mean by z value? So you take this, you take away the mean and you divide by the standard deviation and you get a z value for it. And they compare that z value to what the z value is at the critical region. And they would say that if the z value for it being for 0.001, by looking that up on their calculator, they compare the z values. And if the z value is more extreme, if this z value is more extreme than this z value, then that means that you can reject the null hypothesis and you can accept the alternative. So if this, let's say the z value for the critical region was like minus 1.2, and your z value came out and was minus 3, then if you think about what it would look like on a normal distribution, minus 1.2 is where it's significant. If you calculated it for your test statistic and you got that the z value was minus 3, it's clearly more extreme, so it would be something that you can reject. So you don't, I'm not telling you this so that you use this. I'm telling you this so that when you look in Solution Bank, or if you look on a mark scheme and it's talking about z values, I don't want you to think, Mr. Bison hasn't taught us this. What you should do, if it's in a mark scheme, is look at the section at the bottom where it says notes, and it will tell you an alternative way that you could answer the question, which is the way that we do it. The reason I like to do it the way that we do it is because I feel like it matches with the binomial hypothesis testing. It's got the same sense of comparing the probabilities. So if you do see it, and it's in Solution Bank, just check that you've either rejected or accepted in the same way that they have done, but they only randomly do this every now and then for no reason. So just because they do it in that different kind of way doesn't mean that you should do it in that different way. They're just randomly doing it to show you that you can use either method. I'm not quite sure the way that Miss Chalmers has done it with the other class, but I just think this is a better way of us doing this. But if you need to, there is always this idea of standardizing them using the z values, but basically I don't think they're that useful. Okay, so what you're going to do for me after this, we're probably going to come back and do we might do one question on this when we come back after the break. And then we're nearly done, but you might have noticed on the back page I've got some things on conditional probabilities. I'm trying to decide whether we'll do that next lesson or whether we'll do it afterwards, okay? So when we come back afterwards, we might do one of these kinds of questions that we've got here, right? I'm just going to get the mark schemes ready for this.